Hello and welcome to OpenBrIM Platform. In the next few minutes, we'll get you up and running by opening a sample bridge, making a quick parametric change, and taking a fast tour of the key tools: 3D review, visibility controls, finite element analysis, and design reports. Let's start. To create a new project, click New in the upper left. On Project Templates, choose Example Projects, then select Steel I-girder Training Example. In the Create Project window, you can optionally set a name, folder, and team. Then click Create. When the project opens, you'll land in the 3D model view. OpenBrIM projects are fully parametric, meaning you can edit inputs and see the model update instantly. To see that in action, go to Bridge Geometry, then select Support Lines. Change the station value. As you edit it, the software compiles the model and runs the parametric computations needed to update both representations. So you'll see the bridge update instantly in the 3D view. And if you switch to FEA view, you'll also see the analytical model refresh, including the mesh and the spring connections that link the substructure to the superstructure. To undo the change and return to the previous state, click Undo in the upper left. Then click Zoom Extents in the upper right to fit the entire bridge in the view. Next, let's modify a structural element. In the data spreadsheet, click Pier column. In OpenBrIM, the right-click menu is context-aware, so the options you see depend on the specific cell you click. Right-click the section data cell and choose Edit. Then, adjust Start Section and End Section. As soon as you apply the change, you'll see the pier column dimensions update instantly in the 3D view. Now let's do another quick example that shows how OpenBrIM can link parameters together, similar to an Excel cell reference. Go back to Bridge Geometry. Support Lines. Select the support line and change its skew angle. Next, go to your cross-frame settings and find the cross-frame skew input. Instead of typing a value manually, use the Copy Parameter feature to reference the support line skew. Copy the support line skew parameter, then paste it into the cross-frame skew cell so it becomes a live reference, similar to an Excel formula. From this point on, anytime you update the support line skew, the cross-frame skew updates automatically, keeping the 3D model and the analytical representation consistent without re-entering the same number in multiple places. And to return to the original setup, just set the skew back to 0. Now let's make this even better for cross-frame stations using a global parameter and simple equations. First, create a global parameter called CF spacing and set it to 20 feet. Then, in the cross-frame station cells, instead of typing values one by one, enter equations. For example, CF spacing times 0. Then, CF spacing times 1. Once you have those first two rows, you can drag and drop the cell downward, just like in Excel, and OpenBrIM will carry the equation pattern forward automatically. This makes it easy to define consistent cross-frame station spacing without manually entering every value. One more helpful feature: the information button. If you want to understand a bridge component, its parameters, reference points, and how those inputs drive the final 3D model, the FEA view, CAD exports, and documentation, just click Information to jump straight to the relevant page in our docs. From there, you can also ask questions directly using our built-in AI documentation bot. Now a quick tour of the 3D tools. Click Measure Distance. Then pick 2 points to measure. Let's measure the width of footing 1. The measurement appears in the on-screen panel. Click Cutting Plane. Use Station to cut cross-sections at different locations along the bridge. You can adjust Skew to angle the section and use Flip to reverse the cut direction. Try Profile and adjust Offset to move the section. And try Plan and adjust Elevation to shift the cut vertically. When you're done, click the X to close the cutting plane panel and exit the tool. Next, select a pier in the model. Then, open the Visibility options. Isolate shows only the selected object. After any visibility action, you can click an empty area in the 3D window to bring the menu back. Then click Show All to restore everything. Hide hides the selected object. Isolate, same type. Isolates all objects of the same type. Hide same type hides all objects of the same type. Select another object and click Set Rotation Center to rotate the camera around that object. Now, let's jump into analysis. Click FEA View in the upper left to open the finite element model. Use Display Constructed Only or Display All structure to control what you see. On the left panel, select Loading, then choose Future Wearing Surface to display an example loading case. Click Analyze to run the analysis. When it finishes, open the data spreadsheet. Go to FEA and select Node Reaction. Activate Live Load for node reactions. The spreadsheet will show the critical results, and you can click any cell to see which vehicle placement creates that reaction, highlighted directly on the model. Next, go back to the girder construction stage, then switch to Node Displacement. In the FEA view, enable Deformed to visualize the deformation shape. You'll see the results both in the spreadsheet and directly on the model. You can also review forces the same way. Select Node Reaction to see support reactions, or choose Composite Element Forces. And in the FEA view, enable Composite Forces and MWA Moment to display the moment diagram. Finally, let's run a code check and open a report. Click Design to run the code check based on the defined criteria. When it completes, click Report. In the report tree, open Steel I-girder code check to review checks, calculations, and results in detail. Use back to return to the report list. And that's it. You've created a project, made live parametric edits, reviewed the model in 3D, run analysis, and generated a code check report. Thanks for watching. Now you're ready to start building your own bridge project in OpenBrIM.